Hello guys, what's up? Today I want to talk to you about LDS perimeter system for controlling perimeter displays in sports stadiums. So the main subject today will be how to synchronize two different perimeter systems. Well, I will make the record with a demonstration version of the system so that you can see that you can test and see how it is working without having to acquire any license. So, the main idea is that we will have two different systems. One will be called the director and the other will be the directed. The idea is that the director indicates to the directed systems, that can be one or can be many, what playlist and what sequences to play. This can be installed in one computer or in different computers connected by a network. This is the recommended configuration, the ones in the network, because the performance is the best. But if the computer is powerful enough, you can do it in just one system, connect different senders and control two perimeter systems of different specs. The director system will be a perimeter system with a height of 19.6 pixels, and the directed one will be a perimeter system of 72 pixels height. So you can do it with any configuration you want. You do not need to have the same specs in each perimeter system. So let's start both installations. The directed perimeter will be on top, the directed will be in the bottom, and visually you can differentiate them looking at the network icon. Here the network icon that has a gray border is a directed system. The director does not have any border in the icon. So the first thing that you should do is to configure the network. It's easy and quite straightforward. Here you click in the network icon and you can turn the network capabilities on and off. You can select if the perimeter system is a director or is a directed one. What do you want to synchronize? Only the beginning of a playlist or each sequence in the playlist? You have to indicate them what is the port, the network port that we'll be using for communication. In this case, I will have the 8080 for the director and the 8081 for the directed. All of the directed should have the same port number. And here we have to introduce the match size. The match size is the number of characters that are going to be checked to identify a playlist in one system with the others. I mean, if, like in this example, the match size is 2, the directed systems will look at only the two first characters of the playlist name and the sequence name to identify them as to be synchronized. We will see it clear in a minute. Then we will introduce the list of directed systems. We can delete them or we can add a new one. We'll introduce the local host, that is this computer. In all computers, local host means myself, this computer, and the port number that will be separated by a semicolon. We will add it and we'll save the configuration. we will do the same in the directed system. The port will be 8081, the match size is 2. We will say is a directed system, and the synchronization is by sequence. We save it, make sure that the network configuration is on, and then in the directed system we can check that the network is working properly. So when both systems are configured, both systems are on, we can click here and we will see a message. He is preparing to send a message to all of the directed systems to test the connectivity. He has sent one message to this computer we have configured, to this directed system, and it responds in 1.029 milliseconds. The second one is much faster, and so on. This is the time needed to communicate the systems. Generally, in the same computer, it will be half millisecond. In a network, it will be a bit faster. So now we are sure that both systems are communicating. Let's gonna talk about how to name all the playlists and the sequence so that we can select what we want to synchronize. Remember that we have indicated that we want to configure sequences. This means that when the director starts one sequence, we'll say it to all of the directed systems. I am starting this sequence, and the directed systems will react upon that. If we indicated that we only want to synchronize playlist, this message will be only sent when the playlist is started, and when the sequences are changing, it will not synchronize. Right? So, we have said that we use a match size of 2. Look at the playlist names, for example. We have P1, P2, P3, and another characters here, another message that is clear for you. So, the directed system will have the same P1 and one name, P2, one name, P3, one name. So the match size of 2 indicates that he will only look at the 2 first characters to identify that this playlist is the same than this. This has to be synchronized with this. If we indicate here that is not P1, is Q1, so it would not synchronize. It would understand that these are different things and don't have to be synchronized. And the same we will do in the playlist. I have added a prefix A in the director and the prefix B in the directed. So these sequences will not be the same than these, will not have to be synchronized. If we want to synchronize the advert of Crazy Sports, we would have to introduce here, for example, if we want to synchronize it with Tag Heuer, A1. So it would be the same. This should have to be synchronized with this. It's as simple as changing the name here in the configuration of the sequences. Indicate an A here. But first thing first, and let's go to see how we can synchronize one quick action. One quick action is an action that is played. It's to say, the quick action is a characteristic of the playlist. So when a quick action starts, it will play all the sequences, and after that we'll go back where it was. So we will see how to synchronize it. We select P2 for the playlist identifier, and we will select S as the letter of synchronized for creating the IDs of the sequences. In this case, I've set S1 and a Nike advert. in the directed system, S1 and Nike advert. This can be S1 and another product name here, because as we are using only a match size of 2, this will only take account these two first characters, right? So let's start the system in both systems. We have indicated that we want to synchronize the sequence, so it's starting A1, here is starting B2. What is synchronized is the combination P1A1, P1B2 as are not the same. We can change here our sequence in the director, and the director and the directed is not affected. But now let's start a quick action. Imagine that you have a goal, and when there is a goal, you want all the displays to show a Nike advert. So let's go for this. Both systems start the Nike advert at the same time, indicating it only in the director system. When the advert finishes, it goes back to where it was in each system. One will be playing the Turkish Airlines advert, and the other one will be a sponsor advert, completely different. At the same, you can do it with one sequence or with many sequences. The second scenario I want to show you is how to synchronize two systems with all sequences and all playlists. To do it, I have created a directed system that is a copy of the director, and I have changed the configuration of the display so that you can see that they have a different configuration, a different aspect ratio. I've created a system that has 45 pixels height and 128. The director has 96 by 128, so there are different configurations. You can have a perimeter system, or you can have another kind of display. We will talk about it in another video in detail. But the idea is that you cannot use a simple splitter to copy the output of one display to two different perimeter systems. Let's face this scenario. So I have adjusted the number of cabinets to fill all the rendering window. So you can see here you will have 136 cabinets. On the other hand, on the other hand, in the director you will have only 64 because of the size, as we maintain the size of the window. So let's go for it. I have said that the synchronization is by sequence, match size 2, the same in the directed, match size 2, synchronized sequence. So each time you will start one sequence, it will be immediately started by the other system. So this way you can have completely synchronized all the systems in a very simple way. Okay, just in detail: P1A1, P1A1, P1A4, P1A4 is to say the IDs are the same in both systems. That's it. So let's go for the last scenario where we want to synchronize just a single sequence. To synchronize a single sequence, the idea is the same. Is to say, we will say that both systems are in synchronized sequence mode, the same match size, the ports have to match, and what we will do is we'll create some playlist in the first and the second system. Both will have the same ID, so you can identify sequences inside them. If they have different IDs, they will not synchronize. Remember that the directed will understand that a sequence is the same if the ID of the playlist and the ID of the sequence matches. So here named A1, A2, A3, A4 for the sequences in the director, B2, B1, B2, B3, B4 in the directed systems. I want to synchronize school with Samsung, so I change in the directed the ID and set the same of the one that is in the director, so is A2. Samsung now is A2. So when A2 starts here, A2 will start here. Let's start it in different systems, in different sequences, and when A2 enters here, will enter also in the second system. You will see it's going to be now A2, A2. Well, this has advantages and disadvantages, because from now on, after A2 will begin B4, because it will continue from the point of A2. This have to be in mind when designing a synchronized system. Maybe it's more interesting to use quick actions for doing this. We are evolving the system. We are finding new ways to do it, new parameterizations to do it, and will be soon in the market. So this is all about synchronization of perimeter systems. Remember that it is included in the standard version of LDSperimetral. So you have these features just for having the software. You can, if you have a powerful enough computer, you can have two systems in one computer. As you may have seen, there might be some delay when starting the first time the sequences. This is because it's in the same computer. In different computers, this will be much more synchronized. The human eye hardly will perceive this difference. Also have in mind that these displays are far away one from the other. So these little delays are hardly seen by the human eye. If the system is one next to the other, it's more easily perceived. But if the system is one in the grass and another one in the first floor, it's difficult to perceive it. So we can synchronize quick actions. We can synchronize all the sequences. We can select sequences that we want or not want to synchronize. I think this is all for today. Thank you very much for your time, and I hope you enjoy the video. See you soon. Bye bye.